Okay, hi Melissa. I'm just going to write your name. I don't know why, but yeah. Hi Melissa. So this is question 9, I believe, from the test. So I'm using a new graphics tablet here, and I'm just deciding if I like it or not. And at the moment, it's a not. So if it looks a bit messy, it will be my fault. But yeah, okay. So let's just draw the problem. I find it always helps to draw a question when I'm doing one. Okay, so we've got something being projected with a speed of 14 meters per second. Oh, it's quite sensitive, this one. And it's going over a fence somewhere over here. We know it's 5 meters off the ground, so this is 5 meters. But our fence, of course, well, that is 2 meters high. Now, all of this is going to be relevant. So that's 2 meters high. Okay, so your first question is like, I guess, why is there a range of values for D? And D is the distance from where we threw it. Oh, let me just change that. D is the distance from here to here. Yeah. Why is that a range of values? Well, it's because all we're told is that a projectile definitely clears the fence. So I guess the fence could be anywhere really in between, say, right at the start here. So D has got to be greater than 0. That's why we get a range of values. It could be over here, but it could also be further back. And I guess it could be as far back as about there on my diagram. So that's why we get a range of values for D. Now, what are those values? How are we going to figure them out? Well, let's just start with our normal, well, let me do this in a different color. Let's just start with our normal approach to these kind of questions with vectors. My U vector is going to be 14 and 0. Oh, let me just make that 0 a bit clearer. I'm not happy with my new graphics tablet. Okay, my A is going to be 0 minus G. My S, now this is where people normally go wrong. You've got to remember that where you throw from, that is your axis. Yeah, that is where your X and Y axis begin. That is your origin, I should say. Yeah, and so where I throw from, this is going to be my origin, and therefore the displacement, if I want to make sure that this just clears the fence here, then my displacement is going to be d on the x coordinate, because this will now be d all the way up to here. That's my d. And the y component is going to be -3. Now that's what a lot of people miss. That's actually going to be -3. And it's because you're 3 meters below where you started and d meters across, if you like. And that's why that's d -3. Now this question is going to be easy because we can just use s equals ut plus a half at squared. So we can say that d equals 14t, if you like, plus 0t squared. And so we've got d is 14t, but we've also got -3 is 0t minus g over 2, t squared. That can be immediately rearranged to give t is, what is it, root 30 over 7, I believe. And then I can plug that back in to find d equals 14 times root 30 over 7. And I think that comes to about 10.95. And hence, 0 is less than d, which is less than 11, if you take that to two significant figures. Okay, I hope that's cleared that one up for you, Melissa. Best of luck and keep up the hard work. Bye-bye.